Every invention begins with confidence. Someone believes an idea will work. Someone believes the risk is worth taking. Before safety laws existed, progress often depended on belief alone. There were no warning labels, no regulations, no protection. Some inventors tested their ideas on machines. Others tested them on themselves. History remembers the inventions that survived. It rarely remembers the people who did not. This is not a story about failure. It is a record of cost. These are the top 5 inventions that killed their inventors. Number 5. Franz Reichelt. The wearable parachute. At the beginning of the 20th century, aviation was still experimental. Airplanes were unstable. Pilots fell from the sky with no protection. There were no emergency systems. If a pilot fell, survival depended on luck. Franz Reichelt was a tailor born in Austria and living in France. He was not an engineer. He worked with fabric, weight, and movement. Reichelt believed clothing could save lives. He designed a suit that could act as a parachute. The fabric was meant to spread in the air and slow a fall. He tested the design using mannequins. The results were inconsistent. Sometimes the suit opened. Sometimes it did not. Officials warned him. They asked for more testing. They advised against human trials. Reichelt believed the failures came from test conditions, not the design. He believed a rail jump would work differently. In 1912, he climbed the Eiffel Tower. He told authorities he would use a dummy. Instead, he stepped onto the platform himself. Witnesses watched him hesitate. The suit did not open as expected. He fell straight down. The impact killed him instantly. After his death, the design was abandoned. No improvements followed. No one continued the project. The idea of emergency parachutes survived. His version did not. Number 4. Henry Smolinski. The flying car. By the 1970s, technology had advanced rapidly. Cars were everywhere. Airplanes were common. Many believed the next step was combining both. Henry Smolinski was an engineer and entrepreneur in the United States. He believed personal flight should be accessible, not limited to airports or pilots. His solution was simple in theory: a car that could attach wings and take off. Smolinski modified a Ford Pinto. He added wings, a propeller, and flight controls. On the road, it functioned as a car. In the air, it functioned as an aircraft. Early demonstrations attracted attention. The idea felt close to the future. But the design had weaknesses. The attachment points between the car and wings were fragile. Engineers raised concerns about stability. Smolinski continued testing. During a test flight, structural components failed midair. The aircraft lost control. The flying car crashed. Smolinski and the test pilot were killed. The project ended immediately. Flying cars did not disappear as an idea. They were delayed. Modern designs focus on safety systems that did not exist then. Reinforced structures. Redundant controls. Smolinski proved the concept was possible. He also proved it was dangerous. Number 3. William Bullock. The rotary printing press. In the 19th century, information moved slowly. Books were expensive. Newspapers took time to print and distribute. Printing presses existed, but they were inefficient. Speed was limited. Human labor powered most machines. William Bullock was an American inventor working during the Industrial Revolution. He lived in a time when machines were replacing manual work at a rapid pace. Bullock believed information should move faster. He focused on improving how paper moved through printing presses. His invention was the web rotary printing press. Instead of feeding paper sheet by sheet, it used continuous rolls. This dramatically increased printing speed. Newspapers expanded quickly because of this machine. Mass communication became cheaper and more accessible. Bullock's invention was considered a success. It spread across printing houses. Years later, during the installation of one of his own presses, an accident occurred. The machine was large. The moving parts were exposed. Safety guards were uncommon at the time. Bullock's foot was caught inside the press. The injury was severe. Medical treatment in the 1860s was limited. Antibiotics did not exist. The wound became infected. Doctors attempted treatment, but the infection spread. Gangrene developed. In 1867, William Bullock died from complications caused by the injury. The printing press continued operating. Newspapers continued printing. Information continued spreading. Bullock's death did not stop industrial expansion. It did not slow the demand for faster machines. Over time, safety mechanisms were added to industrial equipment. Guards, emergency stops, regulations. Those protections came later. Bullock's invention helped shape modern publishing. It also demonstrated the danger of early industrial machinery. Progress advanced. Protection followed much later. Number 2. Max Valier. Early rocket engines. In the early 20th century, rockets were experimental. There were no standards, no safety protocols, no protective laboratories. Rocket science existed mostly as theory. Max Valier was an Austrian scientist and engineer. He was deeply interested in propulsion and space travel. Valier believed rockets could change transportation and exploration. At the time, this idea sounded unrealistic to many. He focused on liquid-fueled rocket engines. These engines were powerful, but unstable. Valier conducted experiments in small laboratories. Protective equipment was minimal. Explosion risks were understood, but not controlled. Despite the danger, Valier continued testing. He believed careful calculation was enough. In 1930, during an engine test, a critical failure occurred. The engine exploded without warning. Shrapnel from the explosion struck Valier directly. He died instantly in his laboratory. The experiment ended. The research stopped. After his death, others continued rocket development. They learned from early failures. New safety measures were introduced over time. Remote testing, protective barriers, strict procedures. Rocket science eventually led to space exploration. Satellites, human spaceflight. These advances came decades later. Valier did not see any of it. His work contributed to understanding rocket propulsion. It also demonstrated how dangerous early experimentation could be. Number 1. Alexander Bogdanov. Blood transfusion experiments. At the beginning of the 20th century, medicine was advancing quickly. New treatments appeared faster than they could be fully understood. Doctors were experimenting with the human body in ways never attempted before. Ethical standards were unclear. Safety rules were incomplete. Alexander Bogdanov was a Russian physician, scientist, and philosopher. He was deeply interested in human longevity. Bogdanov believed aging could be slowed or reversed. He believed blood transfusion held the key. At the time, blood compatibility was not fully understood. Blood types had only recently been identified. Testing methods were limited. Bogdanov began conducting transfusion experiments. He did not rely only on patients. He used himself as a subject. Reports suggest he believed exchanging blood with younger individuals could restore health. He recorded temporary improvements in vision and energy after earlier transfusions. These early results strengthened his belief. Warnings existed. Some colleagues questioned the risks. Others warned that reactions could be unpredictable. Bogdanov continued. In 1928, he received a transfusion from a younger donor. The donor carried a different blood type and an infection. Bogdanov's body reacted immediately. His immune system rejected the blood. His condition worsened rapidly. Doctors were unable to reverse the reaction. Alexander Bogdanov died shortly after the procedure. After his death, transfusion science did not stop. Instead, stricter compatibility testing became standard. Blood typing became mandatory. Screening improved. Modern transfusions are now among the safest medical procedures. That safety came from earlier failures. Bogdanov believed science could overcome mortality. Science was still incomplete. He did not survive the experiment that helped define medical limits. Progress often appears clean when viewed from a distance. Finished products. Successful ideas. Surviving inventions. What history rarely records is the cost paid before safety existed. These inventors were not careless. They believed in their work. They trusted their calculations. They accepted risks that later generations would never face. Their deaths did not stop innovation. They changed how innovation was tested. Modern safety laws, ethical standards, and protections were written after loss. They were shaped by mistakes. They were built on absence. Progress moved forward. The people who paid for it were left behind. This is fatal origin.